Sorry, we'd left off here, finding the log of 10,000 here and the log of 1 over 1,000. So here we have the log of 0.01. Now let's use a little bit of ingenuity here and realize this is really the log base 10, again, because they didn't show us a number. So that's base 10. And then remember back from, well, I don't know how long ago it was for you, but this is the 10ths place and this is the 100ths place. So this is really the log of 1 over 100. Okay, well that's really, I'll put it down here, the log base 10 of 10 to the negative 2, which means it must be negative 2. Negative 2 is the answer. Cool. So it's really, C was actually the same as B, but because it was written in decimal form, we had to do a little bit of work. All right, now the D one, we're not going to be able to find that with the tricks that we've been kind of using here for A, B, and C, because A, B, and C were powers of 10. 27 is not a power of 10, so we're going to have to use a calculator. Now, unfortunately, I don't have my calculator program because of where I'm doing this right now, so let me just suffice it to say that if you're on a TI calculator, it's this button right here. You type LOG, press that button, 27, and then enter. And what you'll find is the same thing I did when I Googled it, which is you Google log of 27, you'll get 1.431. So check that with your calculator. It should be the same, right? And it's about squiggly equals 1.431. There we go. All set. All right, now let's move on to the next page, which, unfortunately for you, these are all variable bases, so we're not going to be able to use a calculator to do this. We're going to have to do this with our heads, right? So the log base b of b to the 22, well, remind yourself, I'd put it right there, but I'll bring it back, that the log base b of b to the k is equal to k. There's that note right there. So log base b of b to the k, oops, I put in too many of them, is equal to k, right? So that means that this particular one, I guess I can move this right here, this particular one then has to be 22, right? Has to be, because it's got the same base in the logarithm that it has in the exponent, and then they'll unravel each other because they're inverses of each other. Hint, hint. All right, what about this one then? Log base a of a to the negative 19, that must be equal to negative 19. Like that. All right, now for C, let's look at this for a second. It's going to be the same idea as the ones for A and B, but A and B kind of had them written nicely for us. C doesn't have that because it has that fraction in there. So let me remind you of something you learned in section 4.1, which is that this is really of b to the negative 8. Remember, negative powers make fractions like this. So then once we write it like that, then you know, oh, okay, the log base b and b to the power are going to undo each other, and it leaves me with negative 8. Okay, so let's make a note to ourselves. There we go. Here's a note. That the log base b of a fraction like this is going to end up being a negative number. It has to be, because negative powers make fractions. And remember, that's what a logarithm really is. It's an exponent, right? So negative exponents cause fractions. All right, now that's very different from D. D is not looking at it in terms of a fraction. This isn't a fraction, but it's a root. Now remember, we learned in section 4.2 that this is really b to the 1 over 8. Oopsie, I did that wrong. There we go, 1 over 8, like this, right? Which means the log base b and b to the will undo each other and be left with 1/8 as your answer. Which gives us our next note. Oops, and I'll put it right over here. If you have the log base b of a root or something like that, root, right? Square root, cube root, this was an 8th root, then your answer will be a fraction. So looking at e, for example, that's a root. So that's going to follow this note over here on the right. When you're looking at a root, our answer is going to be a fraction. So let's remind ourselves how we rewrote this in chapter 4. Let me pull up the 4 notes for a sec. There it is. All right, so this is the chapter 4 notes, page 73. It talks about a rational exponent. And remember, this is when we dealt with it when it wasn't 1 over. 1 over is right here in this definition, when it's 1 over n. And then these down here, this definition is dealing with it when it's p over q, right? When it's not 1 over, but p over. And then what happens is you can break that up. And remember, the 1 over q part is actually a root. All right, so how does that help us? Well, let me go back here. So what this is really saying is the log base a of a to the, now 3 is the numerator because it's the number that a is being raised to the power of, and then the 7 part is the root. What it really is, here, let me show you, it's really a to the 3 to the 1/7, but that's such a giant pain to write, right? But that's what it is. It's saying, here it is. Right, 3 is your power, p, right, and then 1 over 7 is your root part, right there. And what you can do is you can write that as a fraction, 3 over 7, like over here on the left. So, and that's easier to think of anyway, so let's see here. So this is really the log base a of a to the 3/7, which is 3/7. Right? Done with that. So it's abiding by the rule we set up right here, which is that if you have a root, it's going to be a fraction. This one for D was 1/8 because B was raised to the 1 power there. You don't see a power, so it's 1. Down here, for this one, it's 3/7 because A is raised to the 3rd power. Now, F is going to combine all the things we've learned so far. It's going to combine both of these notes because it's a root, but it's also a fraction. So because it's a fraction, we're going to need a negative number, right? So this is the log base a, oops, sorry about that, equals log base a of, this is a to the, now negative makes the fraction part, so 1 over is dealt with by that. And then it's 1 over, let's see, oopsie, there we go, 4 over 9, because 4 is your power, that becomes your numerator, and 9 is your root, so that becomes your denominator. So the answer to this is negative 4/9. Oh, you probably like it here. The negative can be on top. It can also be out in front. Either way, it's fine. Just as long as you have a negative in there somewhere. Now, these are actually the start of the next page. I'm not sure how they ended up here, but that's okay. We'll put them down there. All right. So then we have the log base 4 of 1 over 16. Now, again, we're going to have to think about this note. Matter of fact, I think I'm going to label these. This is note number 1. Just so I can keep them straight. And this one here is note number 2. As I talk about them. All right. So because this one has a fraction right here, it's going to have to abide by note number 1, which is that I'm going to need a negative number. And the question is negative what, right? So you can think of this. This is really the log base 4 of 4 to the negative, because it makes it 1 over 2, because 16 is 4 squared, which means our answer is negative 2. Done with that one. Well, that wasn't so bad. Now, H, I, and J, on the other hand, that's going to get a little tricky. So we need to think about H, I, and J just a little bit. In order to make your number turn into something smaller, and I don't mean like a fraction smaller, like the one above was, but I mean like a smaller number. Here, hold on. There we go. I need this down here further. In order to make that happen, you're really taking the root of something. Right? I know it doesn't seem like it, but you are. Here's why. Okay, you need to take 125 to some power and get 5, right? It's possible, but it's only possible if you're talking about roots. Roots, like square roots, cube roots, stuff like that, take powers and make them smaller, right? So let me give you an example. 5 to the third is 125, right? So 125 to the 1/3 would get you 5. You see? To make a number turn into something smaller, which we haven't had up to this point. Well, these were all letter ones anyway. But even back here, 2 went to 32, 5 went to 25, 6 went to 6. That was the same number, so that was kind of special. The only time we went smaller was this one right here, 1. Okay, so we want to go smaller. 0 is too small. Let me just put this out here to you. Let me make another one here. Look, 5 to the 0 is 1. Okay, 5 to the, or excuse me, I'm sorry, 125. 125 to the 0 is 1. 125 to the 1 is 125. So if you want to get 5 out of this thing, you have to take 125 to some power and get 5. It's going to have to be between 0 and 1, right? And the question is, what is it? It's a fraction, right? It's got to be a fraction. So the way to figure out what fraction it must be is to kind of reverse the process like I was doing it for here. I'll put it down here. So let me make a note here. So the answer must be fraction. Let's see if that fit. There it is. So we need a fraction between 0 and 1. Now, how do you figure out what fraction it is? Well, you kind of reverse the process. You kind of say, okay, look, I might not know what 125 to the whatever is equal to 5, but I do know that 5 to the third is equal to 1 over 120, or excuse me, 5 to the third is equal to 125. So that kind of gives me my clue. If it's 5 to the third is 125, then it's 125 to the 1/3 is equal to 5, which means this sucker right here is log base 125 of 125 to the 1/3. Ooh, if I could do this. There we go. Which means it's 1/3. Like that. Cool, huh? All right. And I'm going to have to put that note right up here so I have space. All right, we're going to do it again. So if you were lost, that's all right. We're going to do it again. We'll do it right down here for I. Now I can tell it's the same thing because I'm taking 32 and I'm turning it into something smaller. Right? I have to take it and make it tinier. All right, so let's think here. 2 to the 0. All right, let's see. This is log equals log base 32 of, all right, I need to figure out 32 to some power will get me 2. Okay, so let me go down here. Because 2 to the 5th is equal to 32. 32 to the 1/5 would be equal to 2. Ah, there it is. Ding, ding, ding. So it's 32 to the 1/5. He's the one I want. Okay, so this is 32 to the 1/5. And that's going to be equal to 1/5. Like that. Right? And again, to make it smaller, so the root is kind of a trick. It's not just the root, it's to make a smaller number. If you're going to make a smaller number, that's happening with a root, and that's going to mean it's a fraction. Which I guess you could put right up here. The root / smaller number. With the exception of 1, because 1 is 0. Right? If it was the log of 1, that's 0. All right, now what about this one? Ooh, tricky. I'm not only making it smaller, changing 32 to 2 like this, just like I did before, but I'm also making it a fraction. But remember, fraction's got to be a negative, so it's negative 1/5. Now here's why. It's the log base 32 of 32 to the negative makes 1 over 1/5. So the 1/5 makes it turn into 2, and the negative makes the fraction part, which would be negative 1/5. Oh, you probably like the negative in front. That's all right. All right, so there we go.